Okay, so looks like it's about that time again. We're going to get a start here. So, just a couple of notes. First off, I am using a different pair of earphones that have a super long battery life, which is great, but they are noise cancellation earphones, so I have trouble hearing myself. So, I don't know if I'm like talking too loud, talking too soft. So, if you're having trouble hearing me, just kind of let me know throughout because, like I said, I'm having a lot of difficulty hearing my own voice. Second, I'm going to ask that you ask questions. So I've said it in the Discord channel. I'd like you to ask questions in the calculus questions and stuff like that, just so that the general channel is not filled up with a bunch of calculus questions. That just is going to get too confusing, I think. So I'm going to try leaving the general channel more for like all my classes type stuff. So again, if you have a question, please ask it either in the stream chat or ask it in the calculus question chat. Okay, so I hope everyone is doing good today and ready for a new problem. I'm pretty excited about that. This is honestly, we kind of did the first two problems. The reason I set them the way I do is those are kind of the hardest ones. Everything from now on just gets a little bit easier as time goes by. I'm not going to say it's easy. I'm just saying it's easier. They're more straightforward in terms of things that we have done before, so they should feel more familiar to you. Anyway, so the plan today is I'm going to start with question 7, and that's going to actually be fairly quick. I got a chance to work through it today, so it's going to be fairly quick. And then we can go through and see if there's any questions in regards to the one I asked you guys to do, and that was number 6. So that being said, let's begin. So looking at this one, we have seen this before. So the very first thing they're asking us to do is they're asking us to graph this function that we're given on, so we're asked to graph this, the slope field on, why is that still there? So they're asking us to graph that slope field on the points given. So a quick reminder on how that's done. We've done this before, and it's pretty easy. The way this works is, and again, a lot of this you can just do in your head, but I'll just kind of go through a couple points just to remind you. So what I'm going to do is I'm going to choose a point that's given. So for example, maybe I choose this point right here, the point 1, 1. So I'm going to plug in 1, 1. I'm going to plug in 1 for x, 1 for y. So I get 1 squared, 1 minus 1, and that, I'm sorry, I wrote that wrong. 1 minus 1, and I get 0. So the slope of that tangent line is 0. So what I would then do is I draw a little tangent line that has a slope of 0. Okay, and I'm just going to go through and do that for all my points. So what you might want to do is I'm going to give you guys, let's say, like a little bit of a head start, and maybe you can go through and just kind of make the slope field for your own. I want to remind you, the things that we're looking for is you want to make sure that if you have a negative slope, it looks negative. If you have a slope of 0, it's 0. And if you have a slope that's positive, it looks positive. The degree, they're not looking for super accuracy. So like if it's a slope of 3, you don't have to make it exactly a slope of 3. It just needs to be generally more positive. If one is more positive than the other, then make it look more positive than the other. But again, they're not looking for super accuracy here. Okay. So I know some of you are already doing it, but are there any questions on how to make the slope field? Does anyone have a question on that before we go through and finish that up? Otherwise, I'm going to start catching up, hopefully, to you guys. So let's see what we got here. So I'm just going to start plugging in my numbers. So I noticed already, based on this right here, anytime y is 1, the whole thing is 0. So I can go through, those are all zeros. And not only that, anytime x is 0, everything else is 0. So in other words, I've got, when x is 0, it's going to look like that. So I've got to just kind of go through and do that. Let's see what else we have here. at this point, just, when x is actually when so when x is let's start with x being 1. So when x is 1, I just need to worry about the y coordinates. So when y is 0, it's -1. When y is 2, it's 1. So it looks like it's kind of like doing that. And then this is actually going to be symmetric. So it's actually going to all look like this. So that was pretty quick. I know I did that kind of quick, but see if you have any questions on my slope field. If you do, please feel free to ask them in the chat, in either chat. Okay, then let's see here. Okay, let's keep on going then. So I think for part 1, that's all they're looking for. So let's see what I don't know, honestly. Usually, if you're just wondering how they would grade this, my guess is there'd probably be like 2 points. They might give a point for all your zeros and maybe a point for everything else. We'd have to go and look at it, but usually these are worth 1 to 2 points max. Okay, so that's for part A. Let's go on to part B. So while the slope field in part A is drawn as only 12 points, describe all the points that are positive. Okay, so we can so they're asking us basically to even though we're only looking at a small section of this, what's going on? Where is this thing positive? So I think you guys would agree, just kind of looking at this and kind of looking at some of the patterns we saw, it's going to be positive. First off, it's going to be positive when y is greater than 1, right? So if you look at all our slopes, our slope fields, the y values, when those are greater than 1, it's positive. Anything that's less than 1 is negative. And then the x coordinate doesn't matter because the x coordinate is always positive because it's x squared. So what I'm going to say So I'm going to just kind of reiterate that. I'm going to say slopes are positive when y is greater than 1, but I'm also going to kind of note, if you guys note, that x cannot be equal, x can't be equal 0. Because if x equals 0, then it's not positive. So I'm going to say slopes are positive. Sorry, I'm going to fix that. I see it. It's y is greater than 1, not y is greater than 0. So I think that should fit it. See if you have any questions on that. I'll give it a pause there for a second. Give you guys a chance to ask any questions that you might need. Any follow-ups on that? No follow-ups? Okay, then let's continue going. Let's continue going then. Let's look at this one. So this one, if you read through it, it should look very familiar to what we've done before. So find the particular solution for y equals f of x to the given differential equation with the initial condition that it passes through the point 0, 3. Now, I do want to point out, and sorry to yell at you, but I do want to point out where it says y equals f of x, when we are finished, we're going to have an equation where it's solved for y. So we've talked about that they don't always need to be solved for y. In this case, it needs to be solved for y because it's saying y equals f of x, so y equals something. So let's see what we got. So we have our function here, and let's just kind of bring that down. So we have dy dx equals x squared y minus 1. And what they're asking us to do is write a function of y, right? So in other words, we're supposed to take this thing, we're supposed to integrate it. So this is separation of variables. So I'm going to say dy over y minus 1 equals x squared dx. and I'm going to be integrating both of these. So again, I'm going to pause for just a second, make sure concept-wise we are all together. Um, Also, just to kind of make sure, I want to make sure that since you guys have been pretty quiet, just could you just type one to make sure that everything's going through okay and that I know that you guys are actually there? Just making sure that the stream's not having any issues. Remember, we're in the calculus questions and uh, okay, good, good. I see some people in the stream saying, okay, thank you very much. Okay, just want to make sure. Perfect, perfect, perfect. Thank you guys. I just you guys usually tend to ask a lot of questions and you hadn't asking, and that's fine. Hopefully this is making super sense and you're like, okay, yeah, I totally get this. I don't need to ask questions. Great. Okay. So let's keep on going. So we're going to integrate these things. So, and again, this is something we should be comfortable with, but I'll just kind of go through it to keep a nice pace going here. So left-hand side, that's a natural log. So I'll say the natural log of y minus 1 equals 1/3 x cubed plus some c. Okay? Then we have to solve for y. So we're gonna do this. Because I think you guys would agree if the bottom is correct, then if the top is correct, then the bottom has to be true also. So this leaves us with the absolute value of y minus 1 equals e to the 1/3 x cubed times e to the c1. And I see a question coming in. So the question was asked, you only need to write one c, and we do it on the x side. So technically, so first off, technically it doesn't matter what side it's on, whether it's on the y side or the x side, but we do it on the x side because that's what the side's going to go to anyway. But also the reason you don't need to do it on both sides is because if I have a c on the left-hand side and the c on the right-hand side, when I combine them, there's still going to be a constant. So correct. We only need to have it on one side, and that side, you should make it the x side. Okay, so from here, I'm going to let e to the c1 just equal c, because e to the c is some constant. So I'm saying it's some constant, but c is a lot easier to work with. So now I'm going to say y minus 1 equals c e to the 1/3 x cubed. Now I recognize I've removed the absolute value, and we've talked about this before. So let's see if you have a question about why I removed the absolute value or how I was able to remove the absolute value, ask it, but otherwise we'll just keep on going. Okay, so there was clarification. So here's the reason why. So I'm going to do this in, let's say, red. So I'm going to erase it after I'm done. Let's take a step back. So let's say I had y minus 1 equals ce to the 1/3 x cubed. So I want to remind you that when we break this up, normally, if I were to solve this equation, what I would get is I would get y minus 1 equals negative ce 1/3 x cubed, or y minus 1 equals positive ce 1/3 x cubed. But remember, c is just some constant. It can be positive or negative. So when I do something like this, I'm actually being redundant, because c can already be positive or negative. So that's why I can go straight to this, because I'm acknowledging the fact that, yeah, basically there's like a plus or minus in front of that c because it's some c, and that c can be positive or negative. Hopefully that makes sense. And I'll just give a couple seconds here to, perfect. Okay, so I'm going to erase that red stuff because I don't think I'm going to need the room, but I might. Okay, so the kind of the last part that I need to do here is they gave us an initial condition, and that initial condition was the 0.03. So we were told that this thing passes through the 0.03. And the question is, do you have to demonstrate that constants are redundant? And the answer is no. You do not need to do it. You can just go, if you just like the steps that I have here are perfect. You do not need to do that at all. Okay, so let's plug in the 0.03. Actually, before that, if I do that, I'm going to actually just solve for y. It doesn't matter. I can plug in 0.3 now, but I feel like it might be slightly easier to just solve for y now. Yeah, so let's see here. So let's plug in the 0.03. So this is 3 equals CE to the 1/3 times 0 is going to be 0. So I'm just going to be lazy and put in 0 plus, why am I putting in plus? Yeah, plus 1. So I get 2 equals C times e to the 0 is 1, so 2 equals C. So my final equation is going to be y equals 2e to the 1/3 x cubed plus 1. And that's it. That's the entire problem, I think. Actually, before I do, let me double check if there was anything else. Yeah, nope, that's it. So compared to the problem that we did the other day that took like, what, half an hour? And it had all sorts of hard parts. This one was, I feel, maybe I'm wrong, but I feel it's pretty straightforward and relatively easy and quick, right? I probably, even talking about it, I probably did it. I did it in 16 minutes, and part of that was introduction. So again, see if you have any questions on that one. Now I noticed the question in the stream was, where'd the absolute values go? Did that get taken care of? Because I answered that a little bit earlier, was that hopefully that made, I'm hoping, I hope I didn't miss that one. I don't read the stream chat quite as much as I read the Discord chat. So I'm hoping that I didn't miss that question, but I did answer it, so I'm hoping that still makes sense. Okay, then, so Naveed, I'm hoping that's you're good to go on that. Okay, so now I wanted to kind of go through questions that you had. First off, assuming that that one makes sense and there's nothing left to go over on that one, because again, it is done. I did want to go over questions that you might have had in regards to, I think it was question number 5 or 6. Yes, 6. Okay, it was 6. That's the one I was planning on going over today. Sorry, not to yell at you guys. That's the one I was planning on also going over today because I know there was probably some issues with it. Okay, so again, if there are no further questions, oh, I'm sorry, and I should have said this at the beginning of the stream, so I'm going to say it now. I have a meeting tomorrow at 10:30, and I've put this on this Discord and everything. So the stream tomorrow will be at 9:30. That should give me plenty of time to finish the stream here and still do my my meeting at 10:30 tomorrow. So just again, tomorrow's stream, which will be covering just kind of your questions in regards to multiple choice, will start at 9:30 a.m. Okay, and again, I have the information on my Discord. But again, that's when it's going to start. So let's keep on going here. We're going to do I'm going to actually just go through full 6. I mean, it's not like I'm pressed for time here, right? There's not another class coming in. I do another one at 2 o'clock. So, but I'm waiting. There's a question coming in. Nope, there's not a question coming in. Okay, so let's do question number 6. Now this one's a little hard just because I don't have, this thing doesn't work out so well, so I kind of need you guys to kind of be looking at your stuff too. I will kind of let's see what I can do here. I don't have a good one of this one, and I didn't rewrite it, so let's see what we can do here. So number 6. Okay, I'm going to see if I'm even. You know what I'm going to? Let me see. Give me a second. I didn't plan on how I wanted to demonstrate this. So Just 1 second. Okay, actually that will work. That'll work fine. Okay, let's go through it. So I'm just going to go through the whole question. I know not everybody had questions on the entire thing, but you know what? Like I said, I have the time, and let's go and do it. And I don't think it's particularly long either. So we have a metal wire whose length is 8 centimeters. You heat up at one end. The table above gives selected values for the temperature in degrees Celsius from the wire, X centimeters from the wire from the end. The function is decreasing and twice differentiable. Okay, so as always, the very first thing we should do, and we probably should have even done on the last one, though I didn't do it because I thought it was a little bit more obvious, but we should have still asked the question, and that is, am I looking at, is the function given, in this case, as presented as a table, is it a position of velocity or acceleration? So in this case, in chat, if you would, if you think it's a, in this case, if you think the table is a position function type 1, if you think it's a velocity function type 2, and if you think it's an acceleration function type 3. Okay, yeah, you guys are right. Yep. It's one. It's one. Nicely done. And again, hopefully, if you're like, how did we figure that out? Though I don't think it looks like you guys are all pretty certain on it. We're looking at our units, right? Our units say that it is Celsius, so that's a position value, right? So let's go through and do the first part. So the first part is estimate t prime of 7. Show your work that indicates your answers. So t prime of 7. So they're asking for the derivative at 7. And again, we're given a table. So what I'm going to do, this is kind of weird. Sorry, I'm kind of looking at my computer as I do it, and I realize that you can't see everything. It's kind of like it's not centered well. So I'm hoping that's not too much of an issue for you guys. Okay, let's see what we got here. So I know that 7 is somewhere in this interval right here. So what I'm going to do is I'm going to say, well, since it's an estimate, it is approximately equal to t of 6, not equal to, minus t of 5 over 6 minus 5. So that gives us 55 minus 62 over 8 minus 6, which gives me negative 7 halves. So negative 7 halves, and they did ask for units, so we are taking distance and dividing it by time. So our distance is, we're taking temperature and dividing it by time, so that is degrees Celsius divided by centimeters. Okay, so, oh, no, you are right. I am wrong. I don't know why I did that. Thank you for catching that. So I am wrong. You are absolutely right. I don't know what I was thinking. So let me fix that. You are absolutely wrong. It is absolutely between 6 and 8. I don't know why, because I can't count, apparently. So absolutely right. So it is t of 8 minus t of 6 over 8 minus 6, which is 55 minus 62. Like I said, I did do part of this morning, so I should have not made that mistake. Okay? But good catch. Excellent catch. See if you have hopefully, so again, I know I made a slight mistake there, so make sure that we're all good. See if you have any questions. I just looked up and looked at my Discord, so just see if you have any questions from that. Hopefully I did not confuse you too much. I'll just keep the confusion down to, the bare minimum. Okay, so looks like you guys are good, so let's keep on going. So next, we have to write an integral, and I recognize, again, you're going to just have to keep things on your side so you can see them. Okay, now I think there was a question, why do we use this equation? So let me just to be clear, in case I missed it, hopefully, I mean, maybe it was already taken care of, but just in case it wasn't, why am I using the slope? And the reason I'm using the slope is, remember what this slope gives me. So when I look at the slope of the line between time 5 and time 6, when I look at that slope, what I'm looking at is I'm looking at the average rate of change. And that's going to give me, the average rate of change is just going to be an approximate value, right? So I can say, hey, look, if the average rate of change between time 5 and time 6 is -7/2, that's an approximate, right? That's an average. So is it exactly at time 7? No, but it's a decent approximation. Okay, so that's why I'm using the slope, because the slope gives us the average rate of change, and I can use that to approximate an instantaneous rate of change. Okay, let's move on to B. It's really okay. So I know this is totally off topic, but on my screen, like like right now, I'm only seeing the bottom half. So if I look on the live stream, I'm only seeing the bottom half where it just says the temperature values. I don't know if there's a way for you guys to see my entire screen, which is kind of terrible. It's probably, I don't know what's going on. I would be nice if you guys could see everything, but whatever. If you do know if you do know a way of fixing that, that would be great, because I don't know. It's annoying me. So let's keep on going here, because I have to move this up, and I know it makes things disappear for you guys. You can see the whole thing. Like right now, I can't see the table at all. Like if I look at my live stream, I can't see the table at all. I wonder if I click on it or if I full screen it. Oh, okay. Yeah, it's because I'm not in full screen. Okay. Okay. Sorry about that. I guess it's just me being super old and not understanding how technology works. Okay. Let's keep on going. Sorry about that. Okay. So the next thing they ask us to, um, let's see what they're asking. Next things they're asking us to do. So now I can't, the thing now is I can't see your, okay. So let me get back out of there now that I know you guys can see stuff. Okay. Write an integral expression in terms of T of x for the average temperature of the wire. Estimate the average temperature of the wire using a trapezoidal sum. So this is I think you guys would agree, this is almost exactly what we did the other day. They're asking for the average temperature. This is an average value question. So I'm going to say 1 over, I think it was from time 0 to 8, or so 8 minus 0, the integral from 0 to 8 of T of x dx. Okay? So this is the formula. This is what I'm going to be figuring out. So before I go and figure this out, are there any questions on just the sub? Again, this is very similar to what we did the other day, though. Okay, then let's go and figure out. So we're asked to do a trapezoidal sum. I want to remind you with a trapezoidal sum, I am not looking at these are trapezoidal sums, so we're just coming up with trapezoids. They do not have to have equal base. This is not the trapezoid rule. So I'm going to say 1/8, and now I'm going to calculate this integral value. And the way I'm going to calculate or approximate it is I'm going to use the table values. I'm going to come up with trapezoids. So remember, the trapezoids, it's going to be the average of the bases. So 100 plus 93 times the height. So the first height is 1. Now I'm going to go to the second trapezoid. So that's 1/2 93 plus 70. And the base, that base is 4 plus 1/2 times the next one. I left off at 70, so I think it's 70 and 62. Easy to get kind of lost here. And that base is, again, 1 plus 1/2 times the last, ones which are 62 and 55, and that base is 2. Okay, and this is fine. We can stop here. If you want to, of course, you can go and evaluate this. I'm going to cheat. And now they do ask for units. So whatever we do, you do need units here. So I could say this whole thing, and it'd be degrees Celsius. Remember, when we do the average value, the units stay the same. So this is degrees Celsius. If I wanted to clean this up, again, this is non-calculator, so I probably wouldn't. I'd probably stop here. But if you, just for us here, if you want to clean it up, it becomes 75.687 degrees Celsius. Okay, but again, you do not need to get there. You can stop at that long string of values. That is a number. Okay. Before I continue, do you have any questions on letter B? Okay, then let's move on to C. I'm going to actually erase so that I can see the questions. So let's get rid of that. Okay, so for C, what is it? Find from 0 to 8, find t prime of x and indicate, find that value and why can't I read? Okay, and indicate units of measure. Explain the meaning of that in terms of the temperature of the wire. Okay, so first off, when we are asked to do this, this should be kind of screaming out to us. This is the fundamental theorem of calculus right here. So this right here by flashcard equals this. Okay? And what that represents is it represents the displacement or the change from, in this case, distance 0 to distance 8. It's the change in the temperature of this thing, this piece of wire, from the starting point, right, where the fire is, to the end point of this length of wire, to the end of that wire. Okay? So before I go and evaluate it, because the evaluation is, there's not much to it, are there any questions on what it means or how I came up with what I have here? Okay, so let's see. T of 8 is 55, and T of 0 is 100. So that is negative 45. That's not a 5. 45 degrees, and our units are going to be degrees Celsius. So what this tells me is that the temperature is 45 decreases by 45 degrees Celsius from the starting point where this thing is lit. So I'll write that out, see if I can write that a little bit better. But that's basically what this is telling me. The question is, how do you know what it represents? So first, the reason I know this is, so when I take a step back, when I integrate this thing, right, I'm going back to a position function. So I just went to a position function. When I evaluate this, this is saying the displacement. This is our definition of displacement. So it represents the change from time 0 to time 8 by definition. That's one of the ways we defined this integral, as we said it represents a displacement. Hopefully that makes sense. Okay, so let's keep on going here. Let me kind of put down the wording here. So, and I'll kind of point out what I think are the important words here. So first off, I think it's really important. This piece right here is really important. The decreases 45. And the reason I think it's really important is you were saying, I'm acknowledging the negative sign. I'm acknowledging the negative sign, and I'm saying it represents this. It physically represents something decreasing. So the next question was just to kind of follow up on the first part again was if it's a displacement, why is it not an absolute value? And the reason is a displacement can be both positive or negative. So what I mean by that is if the temperature increased by 5 degrees, we'd say, well, the displacement was a difference of positive 5 degrees. But in this case, we had the temperature decrease by 45 degrees. So its displacement is 45. So displacement is signed. In other words, it can be both either positive or negative because a change can be, we can increase something or decrease it. Okay, so let's continue on writing this explanation. So the temperature decreases 45 degrees. Okay, so I would say again, my guess is when they are grading this, what they are looking for is this. This is the most important part, and the second part would probably be over what distance. So from, whether it's from 0 to 8 or whatever that you're acknowledging, usually we want to acknowledge the domain values. So in this case, from 0 to 8, or from the start of the heated point to 8 centimeters away, or in this case, to the end of the wire. Okay? Before we finish up C and go to the one that a lot of you guys seem to have questions on, see if you have any questions regarding C. Okay, then let's move on to the one you guys had questions on. So I'm going to erase again, just so that I can see what's going on here. Okay, are the data in the table consistent with the assertion that the second derivative is positive for every x value on the interval from 0 to 8? Explain your answer. Okay, so now we're looking at the second derivative. So here's what I'm going to do. If I'm looking at the second derivative, I kind of need to know the first derivative. So what I'm going to do is I'm going to be using the mean value theorem again. And here's how I'm going to use the mean value theorem. So I'm going to look at the interval from 0 to 1. So I'm going to say t of 1 minus t of 0 over 1 minus 0 equals, what is that, 93 minus 100 over 1, which equals negative 17, which means, right, by the mean value theorem, so which equals some c. There has to be some c in that interval where t prime of c equals negative 17. So, and that's by the mean value theorem. And I'm just going to kind of go through and do that for each of my intervals. And I'll show you why in a minute. What I'm trying to do is I'm trying to give myself some numbers that I can work with. So now I know somewhere on the interval from 0 to 1, there has to be a c. Let's call it C1. There has to be some c where it equals negative 17. I don't know what it is. Is it negative 7? Did I add wrong? It's negative 7 because I can't add. Again, I'm having difficulties with basic math. Thanks for the correction. Yes. So I know there's some c in that interval where it is negative 7. Okay. Let's keep on going. So now let's go to, and I don't know if I would show all these things. Let's just kind of go through it. I want to make sure this process makes sense. So the next one, I'm going to look at the interval from 5 to 1, or 1 to 5, should I say. And that's going to be 5 minus 1. So that equals, what are our values here? Sorry. That is 70 minus 93 over 4. And that's going to be equal to, what is that? That's 13. Looks like negative 13 fourths. And negative 13 fourths is equal to about negative 5.75. And that's going to equal to some other c, right? So let me clean that up. So there has to be some other c value so there has to be some c2 in that interval again, where that second value equals negative 5.75. Okay, so one of the things I'm noticing already is if we look at these two intervals, if we just look at this interval and this interval right here, notice that if you were to take, actually I'm sorry, I'm going to backtrack just 1 second. Is everybody okay so far with what I'm doing here? I'm trying to basically find some different, oh my goodness. Is it negative 23? Yes, it is. Why did I write 13? Did I even say it? It is. Sorry, man, I should be a little more careful here. Absolutely right. It is equal to negative 5.75. I meant to write down a 23 and I wrote down a 13 for some reason. Yeah, you guys are right. Okay, so before I continue though, concept-wise, and I'm just going to put down by MVT. Concept-wise, are we okay with these things? Again, I want to emphasize why I'm doing these. I'm trying to find some t prime values. I now can say t prime of c1 equals negative 7. T prime of c2 equals negative 23 fourths. I now have a couple t prime numbers. Again, I don't know exactly what those c values are, but I know they have to exist. I have them. Okay? So now what I can say is, let's just kind of look for a second. So let's take, and this is going to maybe seem a little weird, but let's take t prime of that c2 value and subtract it from t prime of that c1 value. And I know it's a little weird because we're using c2s and c1s, but the logic should work. Let me clean this parenthesis up. So what happens here? Well, t prime of c2 we said was negative 5.75. T prime of c1 is negative 7. And c2 minus c1's always, the thing I need to know is it's always going to be a positive number, right? Because I'm increasing my distance away from that starting point. So in other words, I'm going to get, I think you guys would agree, I'm not going to even worry about simplifying this. This is going to be some positive over some positive, which means right here, the second derivative is positive. I don't know what it is, but it's positive. So far, I'm like, oh yeah, looks like, right? So far, the data is indicating to me that the second derivative is positive, at least for this first interval. I'm going to keep on checking a few more intervals, but so far, it looks pretty good. In regards to that, because I think this is the key to the problem. This right here, again, is the key to the problem, is understanding that I can basically apply, it's kind of like applying the mean value theorem twice, is I now know that somewhere in the interval from C2 to C1 or C1 to C2, that the derivative has to be positive. Again, I don't know what that thing's going to be, but it has to be positive. Meaning I don't know what that C value is going to be. Okay, let's keep on going then. So let's see, I just did T5, T1, so let's do, what's the next one that we have on here? It is T5 to T6. So I'm going to say T prime of 6 minus T prime of 5 over 6 minus 5 equals, so what are our values here? So T prime of 6 is 62. T prime of 5 is 70. And it was over 6 minus 5 is 1, so this is negative 8. Okay, so now let's just kind of look at this really quickly. So I'm going to go and kind of do the same thing I did before. I'm going to kind of repeat my line here and see what happens. So there's a question coming in, so I will do before I do that. So the question is, why is it? Um, oh, it is. It is. I don't know why I put primes. You're right. I don't know why I put primes. Excuse me. No, you're right. Man, lots of mistakes today, but good catches. Good to see you guys are awake. Well, I apparently am not. Okay, so let's keep on going here. So now I'm going to kind of, like I said, I'm going to kind of do my logic before. So if you don't mind, I'm going to say this is going to be equal to some t prime of some third number, C3, right? And again, this is by mean value theorem. So now I can say, let's see, t prime of some C3 minus t prime of some C2 over C3 minus C2. And again, plugging in our numbers, so t prime of C3 was -8 minus t prime of C2 was -5.75, so minus a -5.75. And again, C3 minus C2 is positive. Notice what we get here. I'm going to get a positive number, negative number here. I think you guys would agree, right? This is going to be -8 plus 5.75, so we're talking what? -2.25. So I'm going to get a negative number here, which tells me that in this interval, there has to be a time where the second derivative is negative. So I'm going to be specific here since I do see there's an issue here, and hopefully I do the math right. This should be, so -8 plus that is -2.25. So I'm going to say this is going to be equal to -2.25 over C3 minus C2, which has to equal, and again, I know we don't know what those C3 over C2 is, but we do know it's a positive number, but that's going to have to equal T double prime of C in that interval, right? There has to exist some, we'll call it C4 if we want to. There has to be some number in that interval from C2 to C3 where the second derivative is negative. So my conclusion is that how do I want to phrase this? Basically, I'm going to say T double prime of X is not always greater than 0 because in this interval, it has to be negative. So let's see if I can phrase that. So actually, let's take those C2 and C3 values. Those occurred, where were those values occurring? Just to make sure, I'm going to kind of give myself some real numbers here. So C2 occurred in the interval from 1 to 5, and C3 occurred in the interval from probably 5 to 6. So I can say on the interval from 1 to 6, okay? So that would be my explanation. Again, the key here, a couple key things. I was using mean value theorem to justify these things. Okay, so by mean value theorem, these are these negative things. I should probably indicate again that I was using mean value theorem here. So by MVT, I just kind of want to say how I'm using these things. So by MVT, this is not particularly clean in terms of my explanation, but in terms of what they're looking for, what they're going to be looking for is one, that you've obviously found that interval, so that their original statement was false, and that I was able to come up with these values, and I came up with these values using MVT. I think if you've got that, you're good to go. Whether it's super clean or not, that's up to you. Do you have to include the theorem? Yes. So the question is, do you have to include the theorem in your justification? And the answer is yes. You do need to include the fact. So because again, I was doing these things, right? I was doing this stuff. How did I know that was true? I mean, why do that? What's the point of doing it? How do I know it's true? Oh, mean value theorem says that this is going to be true. There has to be some C value in this interval. So I have to use the mean value theorem. Absolutely. So let's see here. Then the question is, I still don't understand why you found numbers for T prime, but you found numbers for T prime, but you use that to justify T double prime. Okay, so we might want to try cleaning this up a little bit now that we've gone through it. Maybe give it a little bit better of an explanation. So maybe I'll kind of talk it through a little bit more. Like I said, this wasn't super clean, but okay, let's start with a couple things. So the first question was, again, I don't understand why you found numbers for T prime, but use that to justify D double prime. Okay, so here's why. So if you don't mind, I kind of want to erase some things here just so that we can kind of focus on this question. Maybe we'll try to clean this explanation up a little bit and kind of give it a nice AP look to it now that we've worked through it. So I'm going to get rid of this for now. So, and I'm going to just kind of focus on the interval that we found. So the interval that we found, the issue we found it at was from one to what did I do? From 1 to 5, I think it was. 1 to 5 and 5 to 6. Okay, just to make sure. So let's kind of go through and start that part. So again, I'm not starting the problem over again. I'm just kind of reiterating some of the things that we did here. Actually, let's hold off on the questions just for a second. Let me kind of answer. Let me catch up because you guys are a little bit ahead of me. So question number one, again, the question I'm going to start with is why we found numbers for T prime, but then used it to justify T double prime. Okay, so the first thing, so think about what we're given here. Let's think about what we're given. We are given this table, and these are temperature values, right? We are given T temperatures, right? That's what we're given. What are we asked to find? We are asked to talk about the second derivative. So in order to talk about the second derivative, right, I'm going to need to take this position value function that they gave me and take the derivative twice. But how do you take the derivative of a table, right? We can take the derivative of a function, but how do you take the derivative of the table? You don't. What you do instead is we're using the mean value theorem to take the derivative, right? We're using to find derivative values. So what I'm saying is, hey, look, I want to go and find, in this interval right here, I would like to go and find a value for what the derivative must be, right? So in the interval from 1 to 5. So I'm going to start there. So I'm going to say, hey, look, on the interval from 1 to 5. So T of 5 minus T of 1 over 5 minus 1 is going to equal some C value in this interval. So there has to exist. And how do I know this? So, and this is true by mean value theorem. So what this is going to do is it's going to give me some C value. Again, I don't know what it is, but it's going to give me something, right? It's going to give, so I know that at C1, T prime equals this number. So in this case, as we said, when we did our calculations, we got negative 5.75 has to equal this. So what does this tell me? This tells me when the distance is at C1, the temperature is negative 5.75. Perfect. Why is that good? Because now I have a specific value. I have a specific C1 value. So I can say I literally have the point for my derivative value. I have the point C1, negative 5.75, which is important because now that I have that, I'm going to go and do the same thing I did before. So let me backtrack just slightly. I have this, perfect. That's 1 point, right? So if you want to think about it, I have the point C1 and negative 5.75, and this is for the t prime function. Okay, that's 1 point I have. Now I'm going to go find another point, and that point is going to be from t, I think, what was it? I just went to 5, so I'm going to go from 5 to 6. So from t6 minus t5, there has to be a c in that value, in that interval, such that this is true. And again, how do I know that? By mean value theorem. And we found that number to be -8. So now what do I know? At C2, there has to be a value from C2 that equals -8. Okay, so before I continue, I know there's been a couple questions asked, but I'm not exactly sure. I kind of lost in terms of where the questions are asked. So I'm going to stop here for just a second and make sure we understand that I now have two t prime values. I have 2 points. If I were to graph this function, t prime of x, I have 2 points. Point 1 is here. My other point would be here. So I now have 2 points on, I now know 2 specific t prime values. Are we good with that? Is there any questions, any follow-ups from there that we need to ask? Okay, so now I have 2 specific points on my t prime function, right? I have these 2. I'm going to use it. I need to take the derivative again. I need to know what is the second derivative. How am I going to take the second derivative? I'm going to do it the same way I've done here. So now I'm going to say, I'm going to take, that's my highlighter, I'm going to take t prime of C2 and subtract t prime of C1 over C2 minus C1. Why am I doing that? Because I'm finding the slope of the tangent line between these 2 points right here. What's that slope going to give me? Well, I'm taking, remember, if the first one gave me the first derivative, then this one's going to give me a second derivative. So these are average values, but the mean value theorem is going to guarantee that the second derivative equals this value in that interval. Okay, so I can now say, putting in my specific numbers, so t prime of C2 was -8. T prime of C1 was -5.75. If you don't mind, I'm just going to change that now, over C2 minus C1. Actually, you know what? I want to keep the format to what I was doing, so I'm going to move this over just a little bit. So let me, just to make sure it's less confusing. So let's do, or actually I'll just do C. I haven't used C yet. So this is my work underneath here, but this is my kind of my justification for my work. So by mean value theorem. So hopefully that makes sense. See what I'm saying here is I'm saying, hey, look, there has to be a second derivative that equals that value. And now that's going to be equal to t double prime of C. Okay? And what do we notice? This is negative, and then we make our conclusion. We say, hey, look, because this is negative, the second derivative, there's clear as a time where this second derivative is negative, so it can't be always positive like they were saying here, because we found one instance where it was negative. Okay? So I know that was a little bit longer one, but hopefully that was a little more straightforward to you guys. See if you have any questions on that. No? Okay, so let's just follow up here. If at this point we've kind of gone over those two problems, is there anything else that we need to kind of take up care of before we kind of wrap this one up today? So there's a question coming in. So the question is, it only has to fail in one interval? Yes. And the reason is, if you notice what they were saying is in the part D, they were saying, are the data in the table consistent with the assertion that t double prime is greater than x for every x? And we said no. We found one instance, right? So it can't be every x. And that's so because it fails once, that entire statement is false. Another question's coming in. So the question was, why use that interval from 1 to 6? And the reason being is, so I chose from 1 to 6, and the reason being is when I chose my numbers, look, notice what I chose. So in order to come up with the first C1 value, I started at t of 1, right? I started at 1. To come up with my last value, in order to get that C2 value, that was my endpoint on that one. So what that tells me is from 1 to 6, there has to be some value, some C value where the second derivative is negative. Again, is that specific? No. I mean, is that a small interval? No. Do I know where it is? No. But it has to be negative in that interval. And the only reason I'm doing that is because those are my furthest apart pieces. Hopefully that answers that question. Any other questions that you guys have? Is there anything else that we need to take care of before we leave for today? Oh, and again, I do want to remind you again. Perfect. Okay, so again, just a last reminder. Again, tomorrow's stream, 9:30. I'm going over multiple choice questions that you have. What you should do today, aside from maybe hitting some of those multiple choice questions, is could you please make sure you're going through, and I have it written on my thing here, but we should be doing, I think it's number 8. Let me double check before I leave you guys here. Let's see. Nope. This is it, I think. So you guys should be doing number 8. Okay, so that's the one you should be doing. We can ask questions then. Again, I do want to remind you, tomorrow's live stream's definitely going to, I definitely have to get off by 10:30 because I do have a meeting. So it'll be from 9:30 to probably latest, let's say 10:15. I know that's a little shorter, but the multiple choice should be shorter. I probably won't be able to answer questions on problem 8 tomorrow, but Wednesday I should have plenty of time to do those sort of things. Okay, so if you have questions on number 8, probably won't be able to get till tomorrow till Wednesday, unless the multiple choice stuff is pretty quick, which it might be. So if there are no further questions, I'm going to end the stream. And again, as always, thank you all for making it here. Again, if you could pass that word that it will be at 9:30, I'd appreciate that. Okay? Again, thank you very much, and I will talk to you all tomorrow.